Hey guys, happy Tuesday. Today we are going to be talking a little bit about volume. So, in the past, we've talked about area when it comes to rectangles, when it comes to triangles, when it comes to circles, and volume is just taking that two-dimensional area and seeing how that relates to a three-dimensional area. Kind of like if we were taking the surface area of a piece of paper and then taking it to be a whole ream of paper instead. We can find the volume of that rectangular prism. So I know that you guys have done some work with volume in the past, so hopefully this isn't going to be anything too new. But I think what you've done for volume in the past is more involved with rectangular prisms and not with the other shapes. Now that we've been talking more with triangles and circles, we are going to try to find the volume of triangular prisms and of cylinders as well. And believe it or not, the formula for all of them, including rectangular prisms, can be the same formula. What you guys are probably most used to is using the equation length times width times height, because there's three different dimensions for a rectangular prism. And that's what the opening for lesson 23 actually has us do. We know that we can find the area of this by either counting all the squares, but that takes a lot of time, especially the bigger the square or the smaller the squares are. But what we can also do is multiply the length times the width. We've got a length of 1, 2, 3, 4, 5, 6, and a width of 1, 2, 3, 4, 5, 6. Therefore, the area of this square is 36. Right, 36 square units. Now, what this is saying is we can also find the volume of a prism like this. Notice how it now has some depth. The thing is that if you look, this is still a 6 by 6. The only thing that's different now is it goes down 1 as well. Now we do 6 times 6 times 1. The only thing that actually changes there is our unit. Now, instead of 36 square units, it's 36 cubic units. Notice how these are squares, but you can kind of visualize this as cubes being put together there. So if the area of this is 36 cubic units, and we went to cut it in half, what would be the area of half of that right there? Or I'm sorry, the volume of that right there. Well, the volume, if we were going to cut it in half, would be 36, the whole thing, divided by 2. But notice when we do cut it in half, that makes a triangular prism. We can actually find the area of this top face right here. And if we multiply that by the height of the entire thing, we'll get our volume. So to find the volume of any right prism, I want you guys to write this down. The formula for the volume of any right prism, and a right prism is just something that is flat on both the top and the bottom, or flat on two sides. The volume is going to be equal to the base area times the height. Now, when I say base area, that means finding the area of the base that this shape can sit on. Typically, it's the area of the base that would be the same on the other side of that shape. So technically, if we're looking at a triangular prism like this one right here, a lot of you might say that the bottom is the base because that's what it's sitting on. But when you're solving a problem that involves a right prism, you want to take the base that has the same shape on both sides. And in this case, the only one that actually counts, the only face to this shape that only has the same thing on both sides, is this triangle right here. If we take the area of this triangle and then send it all the way back to the back triangle, we will have the full volume of this shape. So, in other words, if I have a triangle with a base and a height, our base is 4, and our height is 1/2, and this is in meters. So if we have that triangle there, we can definitely find the area of it, because the formula for the area of a triangle is 1/2 base times height, or base times height divided by 2. Well, half of our base, half of 4, is 2 times our height, which is a half. The area of that triangle is actually 1. So if you picture putting another triangle behind it, then you would have 2 triangles. If you had 3 triangles behind it, 4 triangles, and so on and so forth. If we were going to keep stacking that triangle all the way back until we reached another triangle back there, and notice I'm not an artist by any means, then we would have a triangular prism. And if we have that triangular prism there, the only other measurement that we really need is the length that it takes to get from the front to the back of that prism. So far, we know that the area of this whole shaded piece right here that I'm shading in right now is 1. That is our base area, 1 meter squared, 1 square meter. But we also have our height, 6.5. So if we label our triangular prism with that 6.5 meters right there, the only other thing that we have to do based on this equation that we have right here is take 1, our base area, and multiply it by, in this case, our height. 6.5, while it is laying on the ground, is our height. Because we want to imagine this if it was this piece, that shaded piece that was on the ground, instead of the piece that it's laying on right now. So if we follow our formula, I'm just going to use BA for base area. BA times H. BA is 1. Our height is 6.5. Then the volume of this is 6.5 meters cubed. When we talk about volume, we put a little 3 up at the top. That we can either call it cubic meters or meters cubed. But what that little 3 represents is the 3 dimensions that we're working with: the length, the width, and the height of this prism. So anytime that you see a little 3 up there, it is talking about volume. While if you see a little 2, we're talking about area, because that's only 2 dimensions, your length and your width. So one other thing that I wanted to talk about today is how we would find the volume of a composite prism. Now, notice this is actually very similar to the problem that we just did. In fact, the shape on the top is exactly the same as the shape that we just did. But what I wanted to show you is that this we can actually find, using the same process, the volume of this. Now, some of you may want to break this apart into the one that we already found and the rectangular prism on the bottom, then add them together, and that's perfectly fine. I wanted to show you 2 different ways that we can do that. So I'm going to draw a picture of this real quick. So we have a rectangle, we have the triangle on top, and like I said, I am by no means an artist. Got the height is 1/2, base is 4, 6.5 back, and 6.5 tall. And this is all in meters. So we've got that shape right there. Now, some of you guys might say, well, we already found the area of that one right there. The top triangle, that was 6.25, or 6.5. So we can find the area of this shape right here. If we chop that piece off, we then have a rectangular prism, which is 4 by 6.5, or 6.5 by 6.5. So we can absolutely find the volume that way. So if I'm going to type that into my calculator real quick, 6.5 times 6.5 times 4, we get that the volume of this is going to be 169 meters cubed. Then if we add on the triangular piece, the piece that we talked about earlier, 6.5, then our total is going to be 175.5 meters cubed. But say we didn't just find the volume of that triangular prism up at the top there, and now we wanted to find a little shortcut. Well, what we could do for this one right here is we could find the area of the pentagon that's up on top. So notice that we do have that shape right here. And it's the same right here. We can still find the area of this pentagon because we know this is a half. We know this is 4. We know this is 6.5. So for this one, 1/2 times 4 divided by 2, the area of this triangle is still going to be 1. So that's the top piece. The area of this on the bottom is going to be 6.5 times 4, or 26. So the total area, the area of the pentagon is going to be 27 units squared, meters squared in this case. Now, if we have that face is the same no matter how far back on the shape we go. If we take that and multiply it by the depth back that it goes, we will have the volume of the shape. And the depth back that it goes was also 6.5. So we're going to take 27 times 6.5. And when we do 27 times 6.5, we also get 175.5 meters cubed. So that's actually 2 ways that we can think about solving for the volume of a right prism. The key here is to find the area of the base that would be the same base on the other side. So in this case, the pentagon would also be a pentagon on the other side. For this one, the triangle would still be a triangle on the other side. If you can find that base area, then all you have to do is multiply it by the height, or how far back it goes. By doing that, you will have the volume of any right prism. So what I'd like you guys to do today is try a few of these. I'd like you to look at number 1, letters A, C, and E. So just 3 problems. Take a look at those 3 problems and see if you can use that formula, base area times height, to determine the volume of these 3 shapes. We'll be talking about it in our Google Meet at 10 o'clock, so I hope to see you guys there. Good luck with it, and we will see you guys at 10.